Working on question number 4. Question number 4 is evaluate the improper integral or state that it is divergent. So in our case, it's the integral of negative infinity to e 11x times e to the negative x dx. So the first thing we're going to do is solve for the indefinite integral. The indefinite integral is anything with respect to x. So in other words, the integral of f of x is an indefinite integral. In our case, it's the integral of 11x times e to the negative x dx, which equals 11 times negative e to the power of negative x minus e, plus c. So the first thing we're going to do is take out the constant in this situation. So the constant is basically a, and we're going to take the a outside of the integral. In our case, it's 11 as the constant, and we're going to take the 11 outside the integral. So then after, we're going to start integration by parts. Integration by parts formula is the integral of u times the derivative of v equals u times v minus the integral of the derivative of u times v. So in our case, u is equal to x. The derivative of x is 1. And v is equal to the integral of e times to the power of negative x. The derivative of that is e to the negative x. The way you figure that out is by using u substitution. In this case, the u is negative x. So if you plug in the u, you'd get v is equal to the integral of negative e u to the power of u du. Okay, so then after, we're going to take out the constant, and taking out the constant is the negative 1. So we're going to take the negative 1 outside of the integral. So it'd be negative 1, the integral of e to the power of u du. And then we're going to find a common integral, which gets rid of the integral, which we get negative e to the power of u. And we're going to substitute the u back in, which the u is negative x. So we'd get negative e to the power of negative x plus c, which is the constant. And so we would get x times negative e to the power of negative x minus the integral of 1 times negative e to the power of negative x dx. If you simplify that, you would get 11 times negative e to the power of negative x minus e to the power of negative x plus c. So once we find that, we're going to solve for the boundaries. Solving for the boundaries is basically using the formula, the integral of a to b f of x dx, which is also equal to f of b minus f of a equals the limit of x to b minus f of x minus the limit of x to a f of x. In our case, our boundaries are negative infinity to e. So if we're finding the limit of x to negative infinity, we're doing 11 times negative e to the power of negative x minus e to the power of negative x, which is equal to infinity, positive infinity. And if we're solving for the boundary of the limit of x to negative or to positive e, we're doing 11 times negative e to the power of negative x minus e to the power of negative x, which is equal to 11 times negative e to the power of negative e plus 1 minus 1 over e to the power of e. So since the answers don't match, that means the answer to this one is divergent.